Algebra 2, Unit 10. Let's continue looking at Core 2 statistical studies with the concept of experimental design. In an experiment, two groups are studied under identical conditions with the exception of one variable. The group under ordinary conditions that is subjected to no treatment is what we call the control group. The group that is subjected to the treatment is the treatment group. This group is given the treatment, which is the variable that has been changed or that is changed. Random assignment is the process of randomly assigning subjects to different treatment groups. Subjects are randomly assigned to the control group or to the treatment group. In some cases, subjects in the control group are given what's called a placebo. It's a harmless, inactive treatment that resembles the actual treatment. The comparison of the control group and the treatment group makes it possible to determine any effects of the treatment. Randomization minimizes bias and produces groups of individuals who are theoretically similar in all ways before the treatment is applied. So conclusions drawn from an experiment that is not a randomized comparative experiment may not be valid. In an observational study, which is something different, the group being studied is only observed and variables are measured without controlling the group members or the environment. In a simulation, a model is used to reproduce conditions of a situation or process. And for experiments, replication or repeating the treatment or the entire experiment in order to yield similar results is very important to ensure accurate conclusions are drawn and can be drawn. So let's talk about designing an experiment or an observational study. In each of the following settings, determine if each is an experimental study or an observational study and explain why. So in a study at Mayo Clinic, researchers wanted to know whether vigorous exercise in older people resulted in longer life. Subjects of varying levels of weekly exercise, ranging from light to vigorous, participated in a study from ages 70 to 85, where the subjects reported weekly exercise routines and received weekly health check-ins. This is a good example of an observational study. Nothing is controlled, just observed. In a diet study using 100 overweight volunteers, 50 volunteers were randomly assigned to receive weight loss counseling, monthly weigh-ins, and a 3-month gym pass. The other 50 were given financial incentives along with counseling, weigh-ins, and a gym pass. The group with the financial incentives lost 6.7 more pounds on average. So this is an experimental study. We have two groups and one treatment group. The treatment, which is the variable which is changed, is the financial incentive. And so everything else was similar and controlled. So the conclusion might be able to be made that the financial incentives affected the amount of weight loss in the volunteers. In a study of more than 4,700 children, researchers from the Cincinnati Children's Hospital Medical Center found that those children whose mothers smoked during pregnancy were more than twice as likely to develop ADHD as children whose mothers had not smoked. This is an observational study. Nothing is controlled. It is simply observed and studied, and conclusions have been made. Now let's analyze some experimental designs. So a pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. Identify a potential problem in the descriptions below with each experimental design. Then describe how you could improve it. The company identifies 10 people who are overweight. 5 subjects are given the new chewing gum and the other 5 are given a placebo. After 3 months, each subject is evaluated and it's determined that the 5 subjects who have been using the new chewing gum have lost weight. So the results sound good, but if we look at how many people are being studied, only 10. The sample size is simply too small to draw definite conclusions. Now look at B. The company identifies now 10,000 people who are overweight. The subjects are divided into groups according to gender. Females receive the new chewing gum and males receive the placebo. After 3 months, a significantly large number of female subjects have lost weight. So, this is a good sample size, but it wasn't selected randomly, and the groups are not similar because we have male and female. So, conclusions drawn may or may not be accurate about the chewing gum. Now, C, the company identifies again 10,000 people who are overweight. This time, the subjects are divided into groups according to age. Within each age group, subjects are randomly assigned to receive the new chewing gum or the placebo. After 3 months, a significantly large number of subjects who receive the new chewing gum have lost weight. So this is a different sample setup. This is a stratified random, divided into age groups and then randomly selected within that. And it is a good size, 10,000. And we do have just one treatment for the treatment group and the control group. And it appears that the groups being studied would be similar. So conclusions made from this study would probably be accurate. To test the new design of its self-checkout, a grocer gathered 142 customers and randomly divided them into 2 groups. One group used the new self-checkout and one used the old self-checkout to buy the same groceries. Users of the new self-checkout were able to complete their purchases 16% faster. Well, the results sound good. We do have a control group, people using the old checkout, and a treatment group using the new checkout. The only thing is we were not told about the size of the sample. We know, I guess we do know the size of the sample. It's 142. We don't know compared to the population, but we do know the size of the sample. What we don't know is the groups. Are the size of the groups the same? But most likely, our conclusion could be valid, or conclusions made from this study. Let's talk about one more thing. So if we are surveying, we need to make sure that we recognize bias in survey questions, either if we're designing or we're taking them. So when designing a survey, it's important to word survey questions so they do not lead to a biased results. So answers to poorly worded questions may not accurately reflect the opinions or actions of those being surveyed. Questions that are flawed in a way that lead to inaccurate results are called biased questions. So we want to avoid questions that will encourage a particular response, maybe because of a particular word or wording. We want to avoid questions that are too sensitive to answer truthfully, that do not provide enough information to give an accurate opinion, and address more than one issue at a time. So look at these example questions and see if you believe that they could introduce bias into their answers. And let's describe a way to correct the flaw. So a dentist surveys his patients by asking, do you brush your teeth at least twice per day and floss every day? Well, that seems harmless enough, but we have some particular phrases, at least twice, and floss every day, that's suggesting something, so encouraging a particular response. My response would be, yes, I do. Also, it's addressing more than one issue. So is the person answering talking about brushing their teeth, talking about flossing, or both? Now, B, do you agree that our school cafeteria should switch to a healthier menu? The question is not worded well because it's asking the person to agree. Also, it's using the language healthier, which implies that the food is not healthy enough and needs to be healthier. So it encourages a particular response. We all want to be healthy, right? Yes. So we would answer yes. C, do you ever attempt the dangerous activity of texting while driving? So we have that particular word, dangerous. This question is probably too sensitive to answer or to answer truthfully, because you don't want to do something, that's dangerous while you're driving. It also would probably encourage a particular response. And then D, how many hours do you sleep each night? I cannot think of a reason why that would make me answer anything in particular. So this question appears to not be biased. All right, that concludes our notes on our topic of experimental design.